Hello, welcome to our first video on EPAS. That's Electronics, PC, and Savvy with Teacher Jeff. So today we will be talking about electronics and making it simple and easier for everyone to understand. So our first topic for today is about conventional current flow versus electron current flow. So we will learn what is the difference and when it is properly used. So first, let's talk about conventional current flow. So imagine this. So a water flowing from the top going to the ground. So the water flows from a higher region and streams down to a lower region. The lowest region is usually called the ground. Okay? So conventional current flow is assumed to behave the same way for convenience because we see fluid behave the same way. So it's quite natural. That's why it's called conventional from the word convenient. It's actually convenient for us because it is something that we observe and we see and we consider is correct and natural. Okay? So the conventional current flow states that the water flows from a higher region to a lower region. Okay? So now let's put it in a circuit. So the positive sign that you see here, that is considered as your high potential region. That is basically your positive terminal or the higher potential region. And the ground here represents the negative terminal, which is the lower potential region. Naturally, the current will flow from the positive terminal to the negative terminal, right? Of course, just like a waterfall, the water will fall from a higher region down to the lower region. So follow the arrows as the conventional current flow dictates. So it's actually quite easier to understand what a conventional current flow because it's basically based on logic and how we see things as it is. Okay, now let's move on to the electron current flow. So in order for us to be able to understand the electron current flow, we have to review some important information or things that we've learned in high school. Let's look at the Bohr's model first. So for the Bohr's model, we know that it has three main parts. Of course, the nucleus, which is at the center, which comprises our proton, which is the positively charged particle, and also the neutron, which is the neutrally charged particle, or well, basically it's neutral. And of course, the floating particles around the nucleus, which is the electron. Okay, so why is it important? We have to first understand, and make sure that we do understand the Bohr's model, because it will eventually explain to us how the electrons or how the current flows based on this concept. So one thing that we have to also remember is that the nucleus contains more than 99.9% of the mass of the atom, which means that the weight or the mass of the particle is located at the center. Imagine that's how heavy it is. And of course, the electrons are bound in the orbit by attraction of protons, but the electrons in the outer band can become free of their orbit by some external forces. So we usually refer or call this as free electrons. So if you would also have noticed on the GIF, the nucleus is also moving, but you also see that the electrons can freely move, right? And because of that, we will be focusing our current flow on the electron itself. Okay. The next concept that we also have to understand the electron current flow is understanding the law of attraction of charges. Why is it important? We have to understand the two basic laws of attraction of charges. The first one is like charges repel. So if you pair a positive charge with another positive charge, they would tend to repel or go against each other. And also, same goes with two negative charges. So they would repel. However, I want you to focus on the second one, wherein the opposite charges attract. So when a positive charge is paired with a negative charge, then they would tend to attract. each other. Okay, so there are two concepts that we have learned now, and we will be using that in our example today. So let's assume we have two terminals, the positive terminal and the negative terminal, which could represent our charges as well. Okay, so from what we have learned, imagine the nucleus is 99.9% of the mass of the particle, which means that the nucleus, which has the proton, the positively charged, is heavier. So between a heavier object and a lighter one, do you think which one would most likely move? Of course, its logic will tell you that the lighter one will move rather than the heavier ones. So we will assume or consider that the terminal, the positive terminal, will be stationary, and the ones that is freely moving will be our free electrons, which is from our negative terminal. Okay, so our direction will be from the negative terminal going towards the positive terminal. So in order for us to be able to even visualize this, imagine that the circle that you see there, the 5 circles that you see there, these are the atoms from the conductor. Okay, of course, the nucleus is not going to move. It will be almost stationary. I said almost because all particles are actually moving, even in a solid state. So, however, the ones that can freely move when we apply additional force, if we will have it attracted um, to an opposite charge, then most likely it's going to be our negative terminal, which contains our electrons. So you will see here that when we put the positive terminal on the other end and the negative terminal on the other end, it will create a complete circuit. Okay, so most likely the electrons will be flowing from the negative terminal to the positive terminal. Let's say we reverse the terminal. How do you think the electron will flow? Of course, the same thing applies. So opposite charges will attract naturally. So they will move to each other. However, the positive terminal or the nucleus will remain stationary. It's still moving, but it's not. It's stationary most of the time. Okay, so the direction will still be from the negative terminal going to the positive terminal. Okay, so now we have clarified the difference between the two. So let's put it in a circuit. So as we have defined before, an electric current is a flow of electric charge. So meaning in an electric current flow, the movement of your electrons or your electric current will be from the negative charge terminal to the positively charged terminal. See the arrow, so you'll be able to follow the flow of electron current in this standard. So if you have noticed, this is quite opposite to the conventional current flow, correct? However, let's go back to our definition that an electric current is a flow of electric charge, or basically the electrons. So are we saying that the electron current flow is correct and the conventional current flow is wrong? Well, let's see. Let's think about it first. When do we use the electron current flow? Generally, we use it when we analyze and understand the behaviors of particle charges in physics. If you still remember your physics teacher, they would always use the law of attraction when they are explaining the class. And also, they are generally used in understanding how doping of semiconductors behave and work, which is why they were able to develop diodes, transistors, and ICs. However, for conventional current flow, generally it's used in electronics when doing circuit analysis or solving electronic circuit problems. The reason for that is that it's easier to understand because it's quite convenient and it's very practical, and that's how we usually see things, right? From a higher potential to a lower potential. Also, it's generally used by electricians when looking at an electrical system, and is used to explain how proper grounding is used as a safety measure in protecting our homes from overcurrent. So now, Which is correct? Well, basically, both are correct. The only key is consistency. If you use one standard or one flow, make sure to use it all the way to avoid confusion. Okay. So remember the conventional current flow. You can just remember or visualize a waterfall for conventional current flow, wherein the natural flow of water will be from a higher potential to a lower potential and eventually to the ground, which is the lowest potential. And the electron current flow is, as we have remembered earlier, we use the law of attraction of charges. And again, the two are both right. They're not wrong. The only key here is consistency. So thank you so much for watching my video. Please subscribe to my YouTube channel. Please search Jeffrey Cadillo. And also, you can look for my Facebook at Jeffrey Cadillo Learning page. And you can also join me at my EPAS class in my Google Classroom with the code on the screen. I will also be sharing this on the link. Thank you so much for your time and have a great day.